Okay, good evening, everyone. Welcome to the October meeting of the RASC. Thanks for coming to the Aviation Museum. Obviously, a change of venue for us. This is a very nice location. I think you can all agree. I wanted to say right at the beginning, I wanted to thank the Museum Corporation for quickly moving us to this facility. They really moved quickly, and it's obviously a difficult time for them. So, very much appreciate that. Okay. All right. Today we've got a terrific meeting, I think. Usual features. Gary's going to talk about the Ottawa skies. Chuck has some breaking news. I'll leave it there. He'll talk to you about something new on his area of interest, which always becomes our area of interest. Something that I've been mulling over in my head for many months is a talk on pyramid alignment. I'll share with you something that I feel particularly passionate about. We're going to have our break. During the break, we'll, as usual, pick up your raffle tickets, and we'll raffle off at the end of the meeting the door prizes that we have. They're open to everyone. You don't have to be a member to participate. Simon's going to talk about a recent trip that he took, and he's got some wonderful material, and only Simon can do that. Lots of observations this month, and actually announcements. So let's get started. Okay, first of all, welcome to new members. This year alone, 51 new members. That's really something. I'd like to welcome Jacob Bonner. Jacob, great to have you here. Jacob, are you here? I think I saw you. There you are. Hey, Jacob. Good to see you. Welcome. We've also got Jacques Bouchard, Martha Farkas, and Matthew Farkas-Dyke are members. Awesome. Norman Fisher, Paul, Hickey, Christopher Jacobson, Jobson, Rachel Jobson, Owen Mills, Alan Robinson. If you're here tonight, it's a delight to have you, and welcome as members. Thanks again. I'm trying to think what will be a new bar to have for membership before the end of the year. We'll see. Let's see where that goes. Some important news particularly for new members. Ron St. Martin, who's our director of the Fred Lassing Observatory. That's our observatory that's part of the Ottawa Centre. He's going to provide training. In fact, the training is tomorrow. So if you want to be part of that training, send quickly a note to Ron St. Martin. If you can't reach him, you can always copy me as well. My email address is mogadam@rogers.com. My email address is at the end of this slide pack. Okay. If you have any questions about that, because I don't think Ron is here tonight, come see me, come see Chris in the break, and we can explain what it's all about. But this training basically tells you how to access the facility, how to use the equipment. It's a well-used facility. Lots of members go there, so it's a great opportunity to start your learning or continue your learning. Okay. Our annual calendars, which are always very popular, the 2015 version, we'll have that available at the next meeting and at the annual dinner as well, and at the December meeting. Price is like it was last year. You can buy one of them for $16 or two for $30, or scale it up accordingly. Okay. Those usually go quite quickly, as you know. We've got a public star party, another one in our series. This is actually coming down to the very last one. It's a week Saturday at the usual location at Carp Library. We've got some backup dates in case of clouds and rain on the 18th, and then the 24th, and then the 25th. And as usual, go-no-goes are posted on the Ottawa RASC website. My experience is that the October meeting, the October star parties are the big ones. So if you haven't come to a star party, this is the one you want to come to. Mosquitoes have come and gone. For whatever reason, we attract a ton of people. The sun sets earlier, so it really works out well. And as usual, if you have a telescope and you're new to it and want some help with it, come early, come a good hour before sunset, and there'll be people there to help you out. The Science and Technology Museum, Melanie Hall, has asked us to support them at a partial solar eclipse that is on October the 23rd. This is one that occurs at the end of the day, right towards sunset. While there's not much opportunity, to see the eclipse, and it's very low, the solar eclipse, and it's very low in the sky, I really feel that we should support the Science and Technology Museum here. They're obviously going through a very difficult time. I don't know how they keep their chin up during this time here, but they've asked for our help. They've asked that we support them, and they're going to be doing observing in Kingston. Okay, so they're looking for people with solar scopes or equipment to at least look at the sun. And I feel really strongly that even though it's a very short duration event, that we help them. So if you are interested and you are available, and I hope some of you are, it'd be a great time a great opportunity to show that we're standing beside the museum. So please see me during the break or after the meeting if you're available to help, and I hope a few of you are. Okay, Bob, why don't you talk about the May Star Party?
So we're going to have our first May Star Party. It's actually going to run tomorrow. Rain date would be next week. It's at Maberly, Ontario on Highway 7 at County Road 36. It's about 20 kilometers west of Perth. Okay, we have really nice dark skies. You can see on the light pollution map here where the cross is. We're just into the darker blue area on that light pollution map. We've got members from the Kingston RASC as well as the Ottawa RASC that are going to be there. The plan was to start at 2 p.m. for solar observing and then hold over at night. There will be coffee and some drinks available as well as some sandwiches. So if you're interested in coming out, the skies look like they're going to be reasonable for tomorrow night so far according to the Clear Sky Clock. So look forward to see you there.
Thank you, Bob. Well, that's a terrific crowd here tonight, by the way. Just awesome. It's nice to see that on a Thanksgiving weekend. Okay, members in the news. I wonder if there's any news. Well, first one is the Saravolas, Deborah and Peter, and once again their image of the Corona Austral. I can never pronounce this. Australis. Is in it's a southern constellation, so that's why I'm having difficulty with it. Southern Sky constellation is in this month's calendar. Well done, Deborah and Peter. Gary Boyle. I mentioned in previous meetings that that Gary is very active with the media. For the Lunar Eclipse, here are the radio stations that he was interviewed on. So well done, Gary. It really helps with outreach and raising general awareness of astronomy, and I think you do a terrific service to our pastime and our interest. Well done. I don't know how you have the time to do it, but you're awesome.
Here do I.
Okay, what other news is there? Just a small announcement that Doug George bought big. So this is really something here. Normally it's the other way around, with a big American company buying up a smaller Canadian company. But this is big news. Doug, are you here tonight?
Yes, I'm here.
Doug, tell us something a little bit about where you see this headed. Can you share with us?
Well, we're pretty excited. We do plan to do more to marry together the software and hardware side of the businesses, and we have some great ideas for new products. So stay tuned.
All right, I'm looking forward to it. I'm sure you do. I'm sure you have something obviously in mind. I'm sure that we're going to see some amazing product and service roadmaps. Awesome. Congratulations.
Thank you.
Actually, I feel pretty proud of that. All right, next up is Gary with Ottawa Skies for this month.
Thank you, Mike. Good evening, everyone, and big crowd, look at that, very impressive. Well, welcome to the Ottawa Skies for October of 2014. Before I begin, I'd just like to mention that I was at Paul Commission's tonight before I come to this meeting. Paul is still recuperating from health issues, but just because he's not here physically, he keeps watching ever since we've been broadcasting. So, hi, everybody say hi, Paul. Hi, Paul. So he's doing well, he's really enjoying the meetings, just like being here. But as soon as he can physically get here, he would like to attend in person. Okay, first slide, please. Well, the one object that we're going to look at this month is NG's. Oh, I did it again. Oops, I did it again. Can I bring it back, please?
Left and right.
Ah, here we are. It's a beautiful little galaxy, NGC 7331, in Pegasus. And as opposed to the regular Andromeda galaxy, M31 or M33 down here, it's a bit of a challenge to find, but it's bright enough. Next slide, please. There we go. And here's 7331, also called the Deer Lick Nebula. And that is 40 million light years away. And there are many other NGCs around the area also. But then it's your guidepost to find the piece de resistance. We have dueling pointers here. The piece de resistance is Stefan's Quintet. Okay, next slide, please. And Stefan's Quintet, the main members of the quintet are about 300 million light years away. So it's not easy object to find, but using 7331, it pretty well guides you right down to these fantastic objects. Okay, next slide, please. Okay, this I've never seen is this month we're actually having comets are found via looking for the planets. And I'll explain right now. In this one we have the planet Saturn, which is pretty well setting. It's very, very low in the sky. And we have, well, if you can pronounce that, you're better than I am. So just say comet 1913 V5. And you can see that pretty close to the date, the actual path be close to Saturn. So yeah, that'd be a great photo op, but again, be very low in the atmosphere. So not too sure how photography will come out on this one. And it is around 7.7 magnitude, so it's a pretty bright comet. But again, being low, a lot of atmosphere. Okay, next slide, please. The International Space Station, which goes around the Earth once every 90 minutes, goes over your hometown, over your city at some point in its orbit. Usually it's 2 weeks in the morning sky, and 2 weeks, a week or two relaxation, and 2 weeks in the nighttime sky. It's always up there, it doesn't relax. It's just how you get to see it, so it's only reflected sunlight that bounces off these spacecraft. So one of the best ones over here is on the 25th. Oh, it should have been this one. Sorry, the 25th. I did the wrong one. It'll be minus 3.3. Next slide, please. So you can see it's pretty well right overhead, right going through the Northern Cross, and just disappears into the shadow over here. So minus 3.3, it's even brighter than Jupiter, not as bright as Venus. So just to give you a ballpark estimate how bright it really will be. So again, on the 25th, check that out. Okay, next slide, please. As Mike alluded to, we have another eclipse. Unfortunately, we missed the lunar eclipse, but people across Canada did get to see it. And that was one main thing with my public outreach to the hilt across Canada, the 756 emails I sent out, but I have distribution lists. So it's really just to bring people out to look at the nighttime sky, to get away from the three T's, the telephone, the TV, and the tablet, and go look at these objects. At these great events, and hopefully it'll inspire some younger people to stay with science and produce the next it in 20, 30 years, probably from that one eclipse. So that was my goal. So again, very, very low here in the eastern sky. I think Kingston's only about 10 minutes more than we'll see.
No more.
Something like that, 10 or 20 minutes, something like that.
No more.
No more?
There's no difference.
No difference at all. No difference at all. So, okay, next slide. And just to show you on the sunset through stellarium.org of how low the sun will be as it just begins to eclipse here from Ottawa. So again, if you're further west, great, you're going to have 2 shows in the same month, which is fantastic. But if you do look at the sun, always use safe filters that's designed for the sun, for telescopes and just for your eye. Or if not, number 14 welders glass, the cheapest and safest way to look at that little bite being taken out of the sun. Okay, next slide, please. And now the encounter that we'll watch on the news, and which you can photograph too, on the 19th of October. The comet Siding Springs will be actually traversing across the planet Mars, only by a mere 140,000 kilometers, which is pretty close. That's about 1/3 the distance between our Earth and Moon system. So that's fairly close. So there will be 3 spacecraft around to be photographing, and 2 other rovers on Mars that will actually be photographing too. So this will be a good photo op, again, for astrophotographers, such as Eric and many out there too, to have the comet right next to Mars. Again, look for Mars, you'll find the comet. Again, never seen that twice in 1 month. And next slide, please. And also here's the comet coming right up from the southern hemisphere. And it's around 10.5 magnitude, almost 11 magnitude. So it crosses here and then goes straight up. So it's getting fainter, but it's really moving, especially now. So keep looking at those charts and try to image it as best you can. And next slide. Well, we had the old time change on Sunday, November 2nd, 2 a.m. You fall back 1 hour, which brings us 5 hours difference from universal time. Universal time is like the Greenwich Mean Time. It's what astronomers use for various events, and you just convert to your own time zone. Well, up to now, for Ottawa, we're subtracting 4 hours, but after the time change, we'll go back to subtracting 5 hours. So that means a difference of missing an event totally by that 1 hour, which you want to do. Next slide, please. And a bit of a different slide here, just our favorite lunar phases. The beaver moon will be on the 6th, full beaver moon. And that should be it for this month. Thank you. Have a good month observing.
Thank you, Gary, for, as always, putting this together. Next up is Chuck O'Dale with some breaking news.
Thanks, Mike. Hi, Paul. How often have you heard breaking news and 100-million-year-old meteorite craters in the same sentence? Well, tonight we have breaking news about meteorite craters over 100 million years old. Let's see if we get this working. Whoop. So, that is Slate Island. I just want you to remember that. I'm going to refer to that later on tonight. But to introduce our breaking news, I'm going to go into where Sudbury is. And I mentioned before in talks that if you ever have a phobia about getting bonked on the head by a large bolide, move to Sudbury. Because right in that very vicinity, there's 2 major craters. The Sudbury Igneous Complex, the one right here, 1.8 billion years old, and Wanapatai, the crater's right inside the lake there, 37.2 million years ago. Now, I'm mentioning this, they are twin craters. It's a coincidence that these 2 craters landed almost in the same proximity. So, as I mentioned, if you're afraid of getting hit by one, move to Sudbury, because the chances of a third one hitting there are fairly slim. So, where is this breaking news? Well, I'm going to zoom in to northern Quebec area, in that area right there. Zooming in, and the first thing you notice, of course, is the Hudson Bay Arc. A lot of people ask me, is that a meteorite crater? And we just don't know. There is absolutely no evidence of an impact there, but that shape, it's compelling to say the least. But what I want to talk about today is just to the right, you notice a twin pair of craters right there. Now, this is the Clearwater impact craters, a pair of craters up there, fairly distinct. The one on the left, Clearwater West, it was dated in 1981 at 290 million years old. And this was by argon-argon dating of the impact melt. It was peer-reviewed, and it's pretty well standard that that crater is exactly 290 million years, plus or minus a few million. Percentage is very, very low. So the obvious implication was, well, the one right beside it has to be the same age. We never had firm dating of it. We've had a lot of samples done, but nothing firm. But what else could it be but a twin crater, a twin impact from a possible double asteroid? Well, in the last couple of years, the research, the tools that we have improved so much that now we have a paper has just been published. It's in peer review right now. There are scientists that do disagree with it, but a lot of data does agree with it. The new age of the one to the west or to the east, the one on your right, is almost twice as old. So Clearwater West, the 290 million year old crater, happened in the Permian just before the major extinction. And the one on the right, Clearwater East, has been dated by argon dating. It's been reviewed and confirmed at 465 million years ago. That's in the Ordovician, when the life on this planet, on the surface of the planet, was just coming on. The title of the paper is Argon Dating of the Clearwater Impact Structures, Not the Binary Asteroid Impact It Seems. Well, I'm going to publish the abstract of this paper on my website this weekend, but I just want to go through a few facts here. The impact melt on the crater on the right, the Clearwater East, that has been dated very, very old, has been, it's a mortification of it. The impact melt, it's called, the geological term is chloratization. I'll let you look that up. But essentially, the impact melt on the crater on the right is much different than the impact melt on the crater on the left, which gave us an indication that, something is different here. But we have supporting evidence as well. And I'm going to read this. This is quoted off the paper, but it's fairly important. Paleogeographic reconstitutions show that the Ordovician East crater, the one on the right, impact probably occurred in a near coastal to shallow marine setting, while the Permian West crater, the one on your left, impact hit on continental Pangaea. Geologically, there are different craters. The Clearwater impact structures are characterized by different natural remnant magnetizations. Essentially, there has been a magnetic field reversal during, there are differentials on each impact. One impact had the North Pole one way, the other impact had the North Pole the other way. This is fairly confirmed, but of course some juries are still out on this one. No resolvable impact contamination has so far been detected in the West impact crater. That's the one on your left, and it's the youngest. But no impact contamination has been discovered on it. Only East Clearwater, the one on your right, carries a distinct ordinary, a possibly type L chondrite impactor signature in its melt rocks. So the melt rocks, again, are different. West Clearwater has Ordovician carbonates incorporated into the impact breccia. These are absent in the breccia lens on East Clearwater, again indicating that they are two separate impact times. Only East Clearwater Lake impact structure is overlain by over 100 meters of post-impact sandstone shells and carbonates. The West does not have this. So with that supporting evidence, plus the dating, there are scientists out there that are absolutely sure that these craters are totally different. They are not a twin impact, which surprises a lot of people. And I'm just going to mention, this is, I flew over these craters. I was flying, let's see if this laser works. I flew around these islands, took a lot of pictures. They're on my website. But this picture, I was right about here looking this way. And that is the common crater rim of the two craters. The one closest to us is Clearwater West at 290 million years, and the furthest one has now been dated at 465 million years. That's in the Ordovician, and the closest one, of course, is in the Permian. So this has changed a lot of opinions because up until last month, everybody thought that it was a twin impact. So we're in peer review right now. More research has been done this summer, and I'm sure there's going to be a lot of papers out on it. So just to conclude, the East Clearwater, I'm just going to show you up here, that one there, that's Ordovician. Now, during about 470 million years ago, there has been a major L-chondrite asteroid breakup, a collision or something. That's your homework for Googling later. But during that time in the Ordovician, our planet took a pounding. We had the Brent crater, just down here. It's just up in Algonquin Park. Lake Couture, where is it? It's up there somewhere. I think there we are. Whoops. Lake Monterey, Pilot Lake, Lake Monterey. All of these are Ordovician, as I say, from the asteroid breakup, and our planet did take a pounding. And just remember now, the Slate Island, that's included in that Ordovician impact series as well. So they are not simultaneous impacts, but they were over the period of the Ordovician time frame. And the West Clearwater, this guy here, they are the same time frame in the Permian as Saint Martin and Manicouagan. So those three were within 10 million years of each other. So that gives you an idea of the time frame and the position. So this has changed a lot of, as I say, opinions of it. And as I mentioned, I'm going to publish the abstract and the title and the authors. There's a string of authors. I didn't want to mention them now. And as I say, it's still peer reviewed. This morning I had an email. Somebody sent me an email about breaking news of crater. I hope it's not earth-shattering. And I said, well, it probably might have an impact. I know it's bad. Sorry. Anyway, so we've got comets flying by right, left, and center. Let's just hope they keep missing us. Thanks very much.
Give you that back.
Oh, thanks very much. Well, good evening, everyone. I'm the next speaker up tonight. I'll be sharing with you my review of research on a topic that's intrigued me for a very, very long time, and that is the highly accurate alignment of the Great Pyramids of Egypt. Tonight's presentation had its genesis on the evening of Friday, March the 7th. Recall that was the evening that Dr. Simmons, she was the McMaster University prof, delivered a presentation on ancient Egyptian astronomy. And like most of you, I thoroughly enjoyed her presentation. I know we talked about it for days and days. But it was something that she told me after the meeting in my car on her way to her hotel that really has kept me spellbound. Now, normally after these meetings, I'm wired and I'm up for several hours. But what she told me that night kept me up for most of the night, reading, and that's really what I want to share with you tonight. So, next slide, Chris. Okay. All right, so Chris is our animator here. I didn't know that. Just wait. I wonder what he's going to do to you, Simon, on your trip to Mars there. So my question to Dr. Simmons was, how could the ancient Egyptians align the face of the Great Pyramid with such incredible accuracy? And as I said, her response is the subject of my talk tonight. So altogether, as of 2008, there were 138 pyramids that have been discovered in Egypt. Most were built as tombs of the country's pharaohs and their consorts during the 2nd and 3rd millennium BC. I'm going to focus tonight on the most famous of the Egyptian pyramids, which are those found in Giza on the outskirts of Cairo. Several of the pyramids are among the largest structures ever built. The pyramid of Khufu at Giza is the largest Egyptian pyramid. That's the one you see here. It's also one of the 7 wonders of the ancient world that are still in existence. this Khufu is also known as the Great Pyramid and the Pyramid of Cheops. On the same Giza location is a somewhat smaller Pyramid of Khafre. We're going to talk about that one, and a relatively modest-sized Pyramid of Menkaure. I'm hoping I'm doing justice to this, along with a number of satellite structures known as the Queen Pyramids and the Great Sphinx. So everything about the pyramids, particularly the Great Pyramid, evokes images of grandness and immense size, but also some mystery as well. So by the numbers, okay, the Great Pyramid of Giza it's estimated to have between 2 and 2.8 million blocks, varying in size from 2 to 65 metric tons. It's 145 meters in height, 200, and as you'll hear in a few minutes, about 230 meters in length is at the base of each of the edges, or at the face. One study by a construction management firm and several Egyptologists, a fellow named Mark Lenner, estimated that the construction of Giza required an average, the Giza pyramid, required an average workforce of 14,500 workers and a peak workforce of 40,000. So without pulleys or wheels, they estimate that this group estimated the Great Pyramid was completed from start to finish in approximately 10 years. Now, with their calculations, they suggest that the workforce would have had to sustain, in order to complete it in that time, a rate of 180 blocks per hour. Okay, that's 3 blocks per minute, with 10-hour workdays in order to put everything in place. So pretty impressive that they were able to do this. Another factoid is that the pyramids, the dimensions of the pyramids are, as I said, extremely accurate. You'll see some numbers in a moment, and leveled within just 2 centimeters over the entire 13-acre base. So this is comparable to the accuracy with modern construction methods and laser leveling. The average deviation of the sides of the pyramid from the cardinal directions is only 3 minutes and 6 seconds. That's right, it's about a 20th of a degree. So the question is, how could this be engineered in a time when, the hieroglyphic records indicate that brute labor rather than tools that were used to construct the pyramids? Now, interestingly, the Great Pyramids rest at a latitude of 29 degrees north, 58 minutes and 51 seconds north, which is just over a 1 minute south of exactly 30 degrees north latitude. Okay, so did the architects of the Great Pyramid intend to build the pyramid at exactly 30 degrees north latitude, or is it a curious fact? Is it a curious fact or merely a coincidence? Okay, this is not the subject of my presentation tonight. Perhaps someone else will want to take this one on, but I caution you that there's a lot of pseudoscience claims out there if you start doing research like I did. So you'll have to be on alert. The base of the Great Pyramids are almost exactly 230 meters long. As you see, they differ only by 14 centimeters. The corner angles are very close to the to 90 degrees, awe-inspiring in many respects. The problem with the pyramids is that there is very little written about them themselves and how they were constructed in the hieroglyphic text, as we read from the temples and chamber walls. And this is why we don't know for sure how they were constructed. We can only speculate about things like ramps, but you can see, in fact, on a hieroglyphic text, ramps are images of people pulling rocks and monument-like structures as in the hieroglyphic text. But pulling a 2-ton rock up a gradual ramp with 100 strong men is one thing. Pulling a 65-ton rock on a flat surface, put aside for a moment that it would have to go on a ramp, is an entirely different thing. And I think this is part of the enduring mystery of the pyramids, considering that this was done nearly 4,500 years ago. Okay, before I go further and attempt to explain, make some sense out of this, it's worth exploring some of my motivations. Beyond our recent encounter with Dr. Simmons, what really kindled my interest? What was it that kindled my interest in the construction and particularly the alignment of the pyramids? So, as an engineer, anything that is even remotely mathematical captures my attention. Clearly, there's mathematics behind the construction alignment of the pyramids, as there is all around us. So allow me for a moment to digress and from examining the question of how the pyramids were aligned, and examined something that I think is at least in my mind, worthy of our attention. And that is measuring the height of a tree in my backyard. Okay, so indulge me for a moment because there is a connection to the pyramids that I wish to establish. Okay, so I have a tree I planted 5, 6, 7 years ago in my backyard, and it turned out to be a fast-growing tree that was initially the source of much pride for me until it started to restrict large parts of the eastern sky. Then I had second thoughts and started to think about how high it was and what can I do with it. Although trigonometry was simple enough, I didn't feel I could measure or even estimate the angle well enough to determine the height and do basic trigonometry. Then it dawned on me that we in Ottawa have a wonderful measurement stick right in the sky, okay? And Polaris, which at our North Star, which at our latitude hovers at approximately 40 degrees above the horizon. So with 45 degrees, we have a very wonderful right triangle that has some wonderful properties. So in a 45-degree right angle triangle, you may recall from high school trigonometry, that geometry, that the rise and the run are the same length in this 90-degree triangle. So I thought, okay, I could use the Polaris in the sky to measure the height of my tree. Because when I walk away from the base of the tree and line up the tree at the tip of the tree with Polaris, I now have two similar triangles. A small one that's highlighted in orange here with a nice convenient 45-degree angle that I can use the height of my tree, and a much bigger triangle with Polaris in the distance, but also showing the 45-degree angle. So what I have, two similar triangles, really basic stuff. So then the tree height is the distance A plus the height of the person. Now that, and let's call that distance P. So the distance A is, given that the rise and the run are the same, is the height. The height of the portion of the tree you see there is also the distance that you're away from the tree. So by walking away from the tree, starting at the tree and walking, I guess, south, at some point you're going to see Polaris peek through the tip of the top of the tree, and at that point you have a 45-degree angle. Add your own height, and presto, you can measure the height of the tree. Really simple. I remember explaining this to my son, and he was looking for an example on similar triangles, and he was mildly interested. But nonetheless, I think it's pretty cool. So in my mind, this is really cool because Polaris is a multiple star system that's 430 light years from Earth, and we just use that to measure the height of a tree in my backyard. So it's worth pointing out that Polaris doesn't sit exactly at the North Celestial Pole. As the Earth rotates, in fact, it revolves around the NCP. And in my case, it varies over the course of the night from 46 degrees above the horizon to a low point of about 44.6. So for my 7-meter tree, the error varies from -10 to +25 centimeters. When I know when Polaris, with my Planetarium program, is exactly at the 45-degree level, I can get a really accurate measurement of the height of my tree, and it yield very, very, very good results. Okay, so back to the pyramids. Enormous structures, 230-meter bases. How could something so large be aligned to the cardinal directions to 1/20th of a degree accuracy? So measuring a tree is one thing. But measuring and aligning a Great Pyramid is something entirely different. Or is it? Let's reflect on this by examining a couple of different alignment methods and that have been considered and that I've reviewed in the research that I looked at to potentially have been used to align the pyramid. This is going to lead us up to the interesting work that Dr. Simmons described to me in that eventful car ride after the March meeting on March 7th. Okay, so similar to the tree example I gave you a moment ago, aligning to a pole star. Here, one method that was considered was to align the eastern or western face of a pyramid to the pole star, okay? Well, unfortunately, back then, when the pyramids were believed to have been erected about 4,000 to 5,000 years ago, the closest star to the celestial pole was Thuban, okay, Alpha Draconis. And as we'll see in a later slide, okay, it really is at best, at closest it got in the last couple thousand years, about 2 degrees from the North Celestial Pole. So it's very unlikely that Thuban alone was used to align the Great Pyramid, and certainly not to 1/20th of a degree to true north. Now, I should say that this method shouldn't be discounted too quickly. It's well documented that the ancient Egyptians had a deep reverence for Thuban and other so-called imperishable stars that did not set, the circumpolar stars. Chamber walls have many descriptions of such stars, and much has been written about passageways from chambers that align with stars like Thuban and others. The thinking being that if you're aligned with them, then perhaps immortality is possible. Perhaps. Another method, and I'm sure it's the first one that came to mind that for most of the people when I started talking about how could you align to the true north, is the shortest shadow method. So at a time of the day, the sun is highest in the sky. Okay, it is by definition right on the meridian. So a shadow on a stick or a gnomon will cast due north at that point, at solar noon. And at this point, the shadow is shorter in length than at any other time of the day. However, the problem with this method is that light tends to bend around sticks, and shadows and shadow edges tend not to be distinct. So it can be very difficult to say for sure what is the true height. A related method here that's described here, okay, beyond the shortest shadow method, is something called the equals shadows method. Now here, as I show in this slide, a gnomon is placed on a horizontal surface. You can see that in the center. And the concentric circles of various diameters are drawn, ideally using a string that does not stretch, okay? So as the sun rises in the eastern sky, okay, the tip of the gnomon shadow crosses the circles and moves from west to east. Now, as the tip of the shadow crosses each circle, the position is marked. First on one side of the meridian, okay, before solar noon, and then on the other side in the afternoon and the evening. So then we can then draw a series of lines to join the intersection points, as you can see in these light orange here. And if we draw a line through the midway point at each of these lines, then it should align with the meridian, okay? So in this technique, multiple measurements should yield a result that's closer to true north than just relying on one shadow and one measurement, or looking at a star in the northern sky that's not quite on the meridian. So here, importance of being on a level ground. I've actually tried this at home. It's really important to be on a level ground. Another method which is interesting is a shadow-based method has been proposed by this fellow Neubauer, and it uses a pyramidal block, and it was suggested that perhaps this could be the capstone of a pyramid under construction. Here, the block is placed first on, again, like before, a level ground and oriented as best as possible such that the eastern and western edges align to the true north. Your best guess, okay? Then two lines are drawn extending out from the eastern and western edges, okay? Here and here. So as the Earth spins, the shadow of the tip of the apex, okay, will intersect these two lines, here and here, this being the shadow line. If these points of intersection are at different distances from the south corners, okay, so if this distance here is not the same as this distance here, and the north-south orientation of the east and west faces are not quite accurately aligned. A slight turn of the base and repeated measurements over many days will yield more accurate measurements. And the thinking being here is that individual measurement errors can be averaged out. But again, think that light bends around corners, and shadows can be indistinct. Another method I bet that many of you thought about was thinking about where where the sun rises and the sun sets. So it rises obviously in the east. By measuring the angle between the two, where it rises, the point that it rises, noting the point where it sets, and bisecting it, we should reach true north. Simple, right? Well, actually, no. Okay. Spotting the movement of the sun rising and setting is very, very difficult to do because, again, light bends near the horizon. Anybody who's looked at the sun at the horizon knows, and even when it's rising or setting, knows that you're looking through a lot of atmosphere. The sun is shaking, and even when the sun is right at the horizon, there's because of diffraction, because of the bending of light, the sun is actually below the horizon. So it's tricky here, and most importantly, you require level ground. Okay, because if you have a situation like this, and the sun is rising in the eastern sky here and setting here, well, that's going to skew your measurements as well. So how do you overcome some of these challenges? And one method that's shown in this slide uses an artificial horizon, this curved brick wall here, and the idea here is that it'll help reduce guessing. Refraction of the horizon because you are above the horizon, okay? So we essentially raise the horizon. But wait a minute now, okay? Now you'll notice here that there is a sighting pole, okay? All right. Now a couple of things have to happen here. First of all, we still need to have this, everything needs to be level here. The brick wall, our artificial horizon needs to be level, needs to be the same height here, here as it is here. This stick here needs to be level. Obviously at the same height above both of these. So how do you overcome this? Okay, it's doable, but how do you overcome this? Well, a couple of different methods have been suggested. We'll look at some of them. One of them was actually suggested to use water. Okay, water when it settles, okay, will give a level surface. Okay. So how do you do that? Do you build a circle and you build a brick circle and flood the whole area? Maybe, but maybe not. It's not the easiest thing to do. The idea seems plausible because the Egyptians had an instrument called a merkat, which is a so-called instrument of knowing. And at the time, it was a timekeeping instrument and involved the use of a bar with a plumb line, which is a vertical line. That became vertical because of a weight that was attached to it. And it was used to track, and I won't get into the explanation of it, but it used to track the alignment of certain stars if they were visible in order to approximate the time at night. And the merkat was typically used with a sighting tool such as you see here, which the Egyptians called a bay, and had a V-shaped right at the sighting tool. You don't see, there's no V shape here, but that's the idea. So what about leveling here? Okay, all these things sort of compound. To help with leveling, here's an example of a level that was used by the Egyptians, and it's well described in the hieroglyphic text. Okay, and the research that I read. You can see here that we have two wood segments that are at 90 degrees. Okay, there is this plumb bob, this line with a weight, and we're going to talk more about perpendicular, these two wooden planks here that are perpendicular and how that was done in a later slide. But when the level is placed on a horizontal surface, the plumb bob line will line up with a previously marked point. So if this point here that the line goes in front of, if it's marked to be level, then we're level, okay? But wait, how do we ensure that this marked point is at the correct location? The level itself needs to be calibrated, okay? So how is this possible? So once again, we come back to what I was talking about earlier. Perhaps you could level it with some water, okay, and sort of help calibrate your leveling instrument that way. Leveling is really important because when I talked about previously about how the pyramids of Giza were aligned over a 13-acre area to 2 centimeters. Obviously, they put a lot of thought into that. Okay, having a pyramid that isn't level might go this way or that way or whatever. So clearly, they were ahead of their time, and they were very exact in their measurements and the use of the tools. Okay, so enter Kate Spence. Okay, Dr. Spence is with the Department of Archaeology in the University of Cambridge, And the study of pyramid alignment became very interesting when Spence submitted an article on this subject to Nature. And it was this article that Dr. Simmons referred me to, which I found very thought-provoking, and really the reason why I'm standing here tonight. Now, her research focuses on pyramid construction, or as she states more precisely, the built environment and material culture of ancient Egypt. Now, Spence wasn't actually seeking to understand why some of the pyramids were aligned so accurately. Her interest was trying to better date them, or date when the construction began, or more importantly, date the time of the pharaohs and the rulers. The chronology of the pyramids has long been the subject of debate, with estimates of the age varying from 5,000 to 7,000 years. Over time, with new research, the estimates conversion and with differences ranging to up to the 80s and 1980s and 1990s to a couple of hundred years. Spence, in her research, as you'll see, was able to reduce that error, okay, to the time of the construction of the time of the what we call the ascension of the pyramids when the alignment was first done, to plus or minus 5 years. So a huge step forward. Now, when Spence's article was published, it immediately caught the attention of mainstream media back in 2000. It also attracted the critical attention of her peers, and the discourse that followed, in which is well documented on the web, and I encourage you to look at it, bordered on acrimonious. But suffice to say, her theory was heavily critiqued. I have to tell you, I read so much about this, and the back and forth, and the criticism and counter-criticism and so forth, that I ended up delaying the delivery of this presentation by 1 month, another month, because I wanted to get the whole story here. All right, let's look what she found here. Deviation of the pyramids. Time check, Chris? Okay. What Spence found was that a number of larger pyramids, the Great Pyramid of Khufu included, had alignments that, when plotted over time, showed deviations from true north that varied for the most part in a linear relationship. Okay, so the earlier pyramids, okay, the faces had some deviation from true north. Okay. The east and western faces. At some point in time, some of these pyramids were very closely aligned to the true north, and so forth. So the dates that you see here were the currently accepted dates at the time that she published her research and when the pyramid's ascension began. That was the view that was the current view of the era of the rulers. She was looking for an anchor date, okay, to help better date the ascension of the pyramids and again the period of the rulers. So Spence wondered if there was something in the sky, particularly around this crossover point, okay, when a highly accurate alignment was possible, that might provide a clue. So she found something. So let's go to a starry night in 2467. So let me take you all the way back to the summer of 67, or the 2467. It was likely a warm summer night, just past midnight, that I depict her with my Starry Night Planetarium program. And what Spence found with her Planetarium program as well was that there was a curious alignment of stars in the northern sky. She found that two prominent stars in the northern sky, Kochub in Ursa Minor, and Mizar in Ursa Major, transited the meridians simultaneously here. So if you were to connect an invisible cord, okay, linking these two circumpolar stars, it would travel through the north celestial pole. Now these two stars rotate around the north celestial pole when they are vertically aligned above the northern horizon, one at the so-called upper culmination, okay, and the other one at the below the north celestial pole at the lower culmination. An alignment made with these stars with a plumb line, okay, will be exactly oriented to the true north. And she called this the simultaneous transit method for obvious reasons. Now we saw earlier, and by the way, here you can see that Alpha Draconis is not quite on the true north. It's approximately 2 degrees off it. So we saw earlier that before and after 2467, the pyramids were increasingly out of alignment, 2467 BC. So what could be the cause of this? So we can see here on this slide that at 2650 BC, before 2467, Our invisible line is no longer accurately aligned to the north celestial, to the north. It's to the right here. Going forward in time, past 2467 BC, or closer in time to us, we can see that the imaginary vertical line has moved further away from the true north. So what's behind this? Well, I'm sure most of you already have figured that out. The answer is precession. Okay, the fact that the Earth spins like a top with a period of 26,000 years. The axis of the Earth, it's at points currently close to our Polaris. Back then, it was close to Thuban, and in many years from now, it'll be closer to Vega. So, as a result of this, the chord between the two stars begins to rotate around the pole. So, as a result, alignments made with this STM, this simultaneous transit method, will deviate from true north in a linear fashion as depicted here. But wait, there are two pyramids that appear to be outliers. We can't just dismiss them and assume that their surveyors were lax and their standards. What is behind this? Okay, so as a result of precession and the invisible core rotating around the pole, alignments made with a particular star, either Mizar or Kochab, its upper culmination will be the opposite side of true north, as alignments made with the same star is lower culmination. So the Khafre and Sahar pyramids are two outliers. Really, then were aligned with the same technique. The only difference being was at the time of the year the alignment was made. Okay, and therefore which star was uppermost. So you can see here that in one case we've got Mizar in the upper culmination. In another case we've got Kochab at the upper culmination. Approximately, it's a different time of the year, February, August. If they were following this simultaneous transit method, and because of the fact that we're closer in time to us than 2467 BC, you can see that there are some differences. So what does this mean? Okay. Well, with this in mind, you could draw a line predicting this negative deviation because of the fact that in one situation there's one of the stars is in upper culmination, and in the other situation the same star is in the lower culmination. So it fits the data very, very nicely. So Spence's model. So with this, she was able to fix a new date to the alignment of the Great Pyramids to plus or minus 5 years. This is this anchor date that she was so keenly looking for. Now, to arrive at these new dates, Spence made an assumption that pyramid alignments occurred in the second year of the reign of the new rulers. And I don't think this is an unreasonable assumption. The new ruler, recognizing that how long it takes to build a pyramid in the period of his rule, probably wanted to get started very quickly on aligning his pyramids and building it. And I'm not an Egyptologist, obviously, but that does seem reasonable to me. All right, so let's go a little bit further here. Okay, and before I finish up quickly here, we've got an alignment to true north, but these pyramids are 230 meters long at their faces. How can we possibly align to the cardinal directions over that great distance here? So here's where the archaeological depictions provide some relief to us. The stretching of the cord ceremony is depicted on a number of temples. Here you can see a cord down here that is held between two staffs, and if you were to separate these two staffs, you can stretch a cord here. At least that's what's described. Now I've got a bit of concern about this, and let me explain to you what my concern was. First, how could you actually stretch a cord, 230 meters, and hope to have some level of accuracy? Egyptologist Martin Isler proposed a method where you could stretch a cord around multiple poles here. If the poles are all aligned within the cords, and the cord would just touch the edge of the poles, then you could say that at least you're aligned on the poles. But in my view, that doesn't necessarily mean aligned to true north. Okay. There is indeed evidence of the post holes being used as suggested by Isler. In fact, you can see them in this photograph here. Okay. I'll leave it up to you, but I think it's kind of a stretch, actually. Sorry, Chuck, I had to. Let me talk a little bit about extending the direction, okay? Now I'm going to come back to the slide here. So one possibility that comes to mind is performing this simultaneous transit method multiple times, perhaps with many crews. Now this would also allow Isler's method to work, okay? And it also perform repeated measurements, going back a slide here. What about establishing perpendicular lines? Well, many of you have probably done this in your home construction projects. It's not a difficult thing to do. One method involves using your let's say this is your north-south line here that you've measured with the simultaneous transit method. You draw two circles with it doesn't matter where they're fixed. Where they cross, those two circles, draw a line straight through them, and you've got a perpendicular. You got to have a taut line here if you want to do this, and you're using a line with some amount of elasticity in it. You're not going to get a perpendicular. Another method that many ancient cultures used was the Pythagorean method here. You measure out your orientation line 3 widths this way, go up 4 lengths this way, and you can make this line will become, this perpendicular line or line will become perpendicular to your orientation line when from connecting from here to here is a distance of 5. Pretty simple stuff, but it in fact does work. Okay, extending the line using an artificial star. Now, one interesting method that was proposed by Glenn Dash uses another Egyptologist, involves using an artificial star, which is similar to the pole alignment discussed earlier. In this case, a sighting block, okay, and a plumb line and a light source, okay, would all be in alignment with the distant light. It would all be in alignment when the distant light, okay, is occulted by the plumb line. So in this case here, the fellow holding the light, or the person holding the light in the back, there's a sight, okay, and there's a plumb line in between, okay. You can line up the plumb line between this U-shaped sighting, okay, and the moment that the artificial light, okay, if that was previously done, if there was another measurement that was previously done, was when all three were in alignment and that light source was occulted by the plumb line. At that point, you would say, okay, everything is in alignment. So doing that multiple times might actually work here. It's worth saying that the unaided human eye has an average resolving power, visual acuity, of about 3 minutes. Okay, now this is one of these terrible average numbers because it varies with pupil size, with age, with spherical aberration, and just vision in general, okay? But 3 minutes is on the order of the best alignment of the Great Pyramid. So how could you align a pyramid to 3 minutes when your eye's limit is at 3 minutes of resolution at the outset? So indeed, some of the alignment methods that were described earlier, the shadow methods, rely on good visual acuity to distinguish lines. But what makes this really interesting, okay, is that, as a researcher named Jeffrey Colby described, it really is a null method, okay? Because it does not require visual acuity. So as long as everything is aligned up, okay, everything is in alignment when the star is occulted by the plumb line and is not seen. All right, so there's no visual separation that is required. Okay, so final thoughts. Okay, did Spence discover how the ancient Egyptians aligned the massive pyramids? Okay. Quite possibly, yeah. Their method seems very convincing, particularly with the numbers that show in the linear relationship and the deviation over time. Very convincing. It only took us 4,500 years or 18,000 generations to figure it out. Now, is it possible that there are other alignment methods that were used? Yeah, it is possible. Daytime and nighttime methods could be used, both of them. Why rely on one method alone? So, with that, thank you. I learned a lot in this exercise, and I hope you enjoyed it as well. Thanks. So here are my references, some of the better ones. Chris tells me I don't have time for questions, so I'm happy to, that's unfortunate, but I spoke too long. I'm happy to chat with you at the break or even after the meeting. This has been a real pleasure, a labor of love to go through this.
How tall is your tree?
How tall is my tree? It's just under 7 meters.
Okay.
Okay, and I do that a lot whenever I see Polaris. Too much. In fact, my wife is always on top of me. I don't have time. Okay, one question, and then we'll have to.
Question. cute little play on numbers with the circumference of the pyramid. 230 times 4 time or multiplied by the inches in a meter is very close to the days of the year.
I heard that, 365.24. There's many 365.24 qubits, I believe.
Yeah, but the numbers are.
There's so many things that I didn't want to share because I'll leave it to somebody else to talk about. But anyhow, folks, really don't have time for questions here. Annual RASC dinner, just before we move to break here. So Gordon Webster, I saw you here earlier this evening. He's got his arm up in the corner there. He'll be selling some tickets for $42. We have a guest speaker, Tim Puckett?
Do we, Gordon?
We might. Rob, his response to Rob Beck, he said he would speak. If selected, I phoned him and sent an email saying he's been selected. He has not responded yet.
So I think we're there, okay? So Tim does a lot of supernova research, okay? He gathers information with remote observatories that people like the Sarabolas and others, amateurs can use to, amateurs can use to find supernovas. So I'm sure it promises to be a very interesting presentation.
He was on an airplane today.
Okay.
And the reason he's on an airplane today is I hired him. So
Yeah, so Tim will be here
lean on him a
because
little
this
bit
is
to try and
boss.
get him to come.
So does that mean we don't have to actually pay
No.
for his? So I'm thinking that Doug Doran knows him really well. Okay. So lots of information about this is Gordon Webster's. As I mentioned earlier, we'll sell tickets tonight and in the November, actually tonight. And the November meeting. Thanks. Al Scott. So Al is going to talk. He's the chair of our nominating committee. He's going to talk about some positions that are open here. And then after Al, we're going to go for break. And as usual, I have our raffle tickets. We've got some door prizes, some of which are in front here, and the others are behind me here. As always, you pick up a ticket and you leave a ticket behind. If we draw your number, you have the ticket. You select your door prize.
Thank you, Mike. So it is my honor as past president of the Society to be the chair of the nominating committee for this year's club elections coming up in December. We have a few openings yet to fill, and if anyone's feeling ambitious and wants to get involved in the club executive and find out how your membership money is spent and maybe direct it to whatever you're interested in, participating in that decision, please contact me. I'm told that the president line is almost gone, so speak up quickly if you want to be president. Also, vice president position is available if anyone is interested, and our Astronauts editor position is opened, and there's always opportunities to volunteer with the club, so if you are interested in volunteering, there's lots of things, talk to Mike, talk to our group. We'd be happy to have you work with us. On the topic of volunteers, I'm also the telescope loan librarian, and if anyone has brought a telescope to return tonight, please see me at the break because I'm not going to be sticking around much longer than that. Thank you very much.
Thank you all. Okay, let's go to break here. So typically some membership benefits for those people who are new members. As I mentioned earlier, there's a Fred Lossing Observatory, and Ron St. Martin will be offering training on that. The TED Bean Loan Library. Of course, with a membership, you have you're entitled to you receive a number of magazines and other literature benefits. Here is the membership rates, and I encourage you, by the way, particularly for people who have come to these meetings and have found them enjoyable, to please consider a membership, because as I can explain later tonight, we have a really great speaker that's coming in, something I'm looking forward to in December, and these things don't happen for free, and in fact, these wonderful rooms like this don't happen for free, so your membership and your paid membership is important to this, to our sort of our ongoing viability. So next up is Simon, who has some many interesting stories to share with us and from his journey. Simon, over to you.
You know, the notion of channels on Mars, that's fascinated mankind for centuries, including Percival Lovell in the early 20th century, who was convinced that he could see purpose-built artificial canals on Mars that were used to irrigate vegetation. Now, while Lovell was dead wrong on all counts, planetary scientists were nonetheless surprised as late as the 1970s when the first orbital probes around the red planet showed just how dry and barren Mars really was. They didn't expect it. Nonetheless, it turns out that there are many natural channels of all shapes and sizes on Mars, attributed to a variety of geological origins in more hypotheses than you can shake a stick at. Now, this can get very confusing if you just read about it. Each proponent is adamant that their hypothesis is the correct one. So I decided to go to Mars to see for myself. Since there are several kinds of channels, let's be clear on what it was that I went to investigate. Now, we can start by looking at what I was not looking for. Chris, if you'd go to the next one, please. There we go. Can I just sort of step out here and see how? Not as bright as I would have liked, but it's good enough. Okay, on the one hand, this is the Mariner Valley, the largest valley network in the solar system. 45 years after its discovery, planetary geologists are still arguing about how exactly it initiated. The major problem is that it has been over-deepened and over-widened so much that its origins are obscured. So I wanted to avoid this kind of this feature. Next one, please, Chris. Now, on the other hand, long, skinny rifts like these have a very special origin that most planetary scientists agree has something to do with some form of collapse due to volume loss beneath the surface. And the debates revolve around just exactly what might cause that volume loss. The problem here is that since the causal agency is buried, we can't see it or investigate it directly, so I struck these off my list too. Next one, please, Chris. What I wanted to investigate is the variety of channels referred to as outwash channels, most of which occur north and east of the Mariner Valley and east of the Tharsis uplift. It's these things here. There's one up there. See this one through here? There's another one coming up through there. These are seen here in a digital elevation map of Mars, though I will also mention a place called Mardin Vallis, which is just over here, or alternatively, it's just over here, which is located south of Elysium Mons and west of Tharsis. Now, red is high ground and blue is low ground. So let's just be clear on what the main geographical elements are. This up here in blue is the northern plains. In reds and yellows through here, this is the southern uplands. This is Syrtis Major. This is the dark spot that when you look at Mars through your telescopes that you probably can see. There's Elysium Mons isolated over here. This is the Tharsis uplift with the Mariner Valley. And these are the giant volcanoes, and this one is Olympus. This is Argyre and Hellas, both major impact basins. I will refer to them during the talk, but I won't be able to bring this slide up there each time. Next one, please, Chris. Now, as we zoom in, we can see two of the principal outwash channels. This is Cassae Vallis, and this is Aries Vallis. And these are respectively the Japanese and Latin names for Mars. Why are they called outflow channels? Because they appear to relate genetically to catastrophic floodwaters flowing out from the Mariner Valley during the early history of Mars. And I'll explain that later. Okay, what are the characteristic features of outwash channels on Mars? Well, first, if you remember that the Mariner Valley here extends the equivalent distance from Vancouver to Halifax, you can see that these are very large features. They can be thousands of kilometers long and tens of kilometers wide, if not 100. Next one, please. Now, Mardin Vallis, as I mentioned, is a small example. It's about 700 kilometers long, so it's small by Martian standards. It's mildly curvilinear. In other words, it's not dead straight. It sort of wiggles mildly, but nothing too much. It has very steep sidewalls, and most importantly, it has no tributary valleys contributing to its formation. There are no major tributaries flowing into that valley. In short, this is not your typical river valley, which would be a system of multiple converging channels or tributaries. By the way, Mardin Vallis emptied downstream into Gusev crater, which is where the Spirit rover was sent by NASA. And I'm not quite sure what it's doing right now. Next one, please. Now, this steep-walled, flat-bottomed form, so characteristic of Martian outflow channels, has even inspired space artists to offer up their visual impressions of what it would be like to be there on the ground. And this is a remarkable image of an artist's impression, and I'll show you what that might be tangibly standing on the ground later. Next one, please. Here's an oblique 3D perspective image from the European Space Agency of Röhl Vallis. Here it's located east of the Hellas Basin. Again, note the slightly curvilinear shape, the very steep sidewalls, and the channel floor, and no tributaries. The grooves along the channel floor that you can see in here, those are likely related to later glacial activity, so let's just ignore those for now. Next one, please, Chris. So here's an overhead view directly down into a segment of one of the channels of Cerberus fossae, southeast, I think, of Elysium Mons. Again, note the vertical sidewalls, the flat channel floor, here with a train of late sand dunes. Next one, please, Chris. Now, in addition to the gently curving outwash channels we've just looked at, there's an entire population of very squiggly channels, like this one, Nanedi Vallis. Like the gently curving ones, they are hundreds of kilometers long, with steep sides, flat floors, and no tributaries. But their key characteristic is their squiggly trace. And at first glance, you might think these are river meanders, but these are more chaotic looking than classical river bends. Next one, please. Here's another example of the same squiggly shape. This is Nergal Vallis between the Mariner Valley and Argyll Basin, and it's just to emphasize the point, but you will see that slide again. Next one, please. So now that you've got a general idea of what outwash channels look like on Mars, let's zero in on one in particular and see what it's made of. And that's Casei Vallis. That's this one here. And we'll be focusing down at that end of it. You'll see why I chose this one in just a minute. Casei Vallis is about 2,000 kilometers long, and it's the best described outwash channel on Mars. And the really good stuff is all concentrated at the downstream end, where it opens onto Cris Planitia. So that's the downstream end here. It comes right from there to there. Now, Cris Planitia is part of the northern plains. And the very best stuff, next one please, Chris, is seen in this red box. So even in this elevation map, we can clearly see that Casei Vallis is made of a series of channels. See the series of channels with multiple channels which even split, and they wrap around various features which include both high-standing and relatively low-standing remnants after erosion. In other words, islands. Next one, please. And this is a photographic representation of the red box from the previous slide. And we can see the same broad features indicated. There are the channels going around, channel coming up through here, coming up on both sides of the high-standing island, the relatively low-standing island. I'll come back to this island several times. And as you come around the top here, you can actually see these streamline features. Those, again, are remnant islands. Next one, please. And I really find that this oblique 3D perspective rendering from the European Space Agency helps to better locate and picture the main elements of the Outwash Channel. So here's one channel coming through here. There's another channel coming around like this. And here's the high standing island I was mentioning. And there, I hope you can see, is the lower standing island. And here are these remnant islands out here as well. All righty. Next one, please, Chris. Now, if we zoom in on that area around the relatively low-standing island, we can see serrations in some of the steep channel walls. I'll show details in a minute, but they're located here, actually in the walls of one of these channels, here on the sides of this low-standing island, and then up here at the head of this lateral channel. Now, what they are, they're dry waterfalls, technically referred to as cataracts. And I want you to remember the location of that red box there on the left. Next one, please, Chris. Think Niagara. Multiple waterfalls separated by dry cliffs. Or Victoria Falls in East Africa. Now, imagine turning off the tap. What would these waterfalls, these terrestrial giant waterfalls, look like? Next one, please. This was Victoria Falls. Maybe I hadn't asked for that one. Okay, there we go. Now, this is a close-up of the red box on the left from 3 slides back, showing what planetary geologists think Niagara and Victoria Falls would look like if the water was turned off. Multiple alcoves cut into steep cliffs up to about 400 meters high. Just let that one sink in. Niagara is nowhere near 400 meters high. Upstream is to the left in this image. By Earth standards, these are gigantic. Next one, please, Chris. Now you can see a similar set of multiple curved alcoves or cataracts. That's about 100 kilometers in length, cut into very steep cliffs on that relatively upstanding island. And again, upstream is to the left. And the next one will show them in detail. You notice that you've got the alcoves here, which would be the individual waterfalls, and then there are these stubby spines of rock sticking out, separating one alcove from the next, one waterfall from the next. And again, I'll be coming back to that. Next one, please. And finally, you can see the same thing at the head of this subsidiary channel. Upstream again is to the left. Here are the alcoves, and then up into here as well. Planetary geologists interpret this particular example by analogy with the Niagara Falls that have receded. They've eroded in a recessional fashion back upstream over a distance of 10 kilometers in 10,000 years since the end of the last ice age. Except that in this Martian subsidiary channel, it's about 200 kilometers long. And the waterfalls would have started here and eroded their way back up to their present position 200 kilometers upstream. Now, by Earth standards, that would seem to be a lot of erosional migration. Okay, catch your breath. That was like drinking from a fire hose. By putting together the presence of dry waterfalls or cataracts that eroded back upstream with the presence of islands as erosional remnants of either bedrock or sediments within branching channels, planetary geologists arrive at the currently predominant model for outwash channels on Mars, erosion by water. But why did I just describe Cascade Valles in such detail? Because it's the only known example of a Martian channel of any kind with cataracts. In short, a lot of stock is being invested by planetary scientists in very few observations. Good observations, but very few. But how do they arrive at the conclusion that the water that created all of this was floodwater, and catastrophic floodwater at that? Computer models. So what's their observational evidence for this? They have none. Instead, they draw analogies with a location on Earth where observational evidence can indeed be found in favor of truly catastrophic floodwaters that carved outwash channels into solid basalt lava bedrock in 3 to 7 days. Now, where is this natural laboratory, you might ask? Well, of course, you already know. It's in the channeled Scab lands of Washington State in the US, and this is what I refer to as Mars. Next one, please, Chris. So last August, I got into my car and I drove 14,000 kilometers to Mars and back, including a 2-week non-stop tour of the channeled Scab lands. Armed with 2 excellent guidebooks, which I've got with me if you want to see them, written by geologists who've worked in Washington, I went to see the analogy with planet Mars for myself. And their story goes like this. Once upon a time, about 15,000 years ago, at the end of the 2 million year long ice age, as the end approached, rivers in the northwestern US that flowed to the Pacific Ocean were dammed by ice. There's the ice dam. This is Washington State here, Idaho, Montana, and the blue there represents the dammed up water. And that dammed up water covered parts of Montana as a lake, 700 meters deep, an equivalent in surface area to Lakes Erie and Ontario combined. And this is referred to by geologists as Glacial Lake Missoula. One fatal day, the ice dam broke. Glacial Lake Missoula emptied in less than a week as its waters rushed to reach the Pacific, wreaking catastrophic erosional havoc on their way westwards, especially in what we now call the channeled Scablands of eastern Washington, and that's what's represented here in the brown, and this is the Columbia River going out to the Pacific Ocean. Next one, please, Chris. Now, the floodwaters from Glacial Lake Missoula cut spectacular outwash channels, the largest being Grand Coulee. The next set of photographs, they're my photographs that I took. There'll be, every now and again, I'll point out that a photograph isn't mine, that I stole it from the internet, but these are my photographs. You may have heard of Grand Coulee Dam. It's nearby, but it's actually not in Grand Coulee. Note its key feature. It's gently curving. It's got steep to vertical walls and a flat floor, and take my word for it, I've driven up and down it several times, no tributaries. Next one, please, Chris. The fundamental difference between these and terrestrial outwash, terrestrial outwash channels and the Martian analogues is size. Grand Coulee is only 80 kilometers long, and its vertical sidewalls are only 100 to 150 meters high, compared with half a kilometer on Mars. Does Grand Coulee remind you of anything? Next one, please. The outwash channels are all cut into bedrock made of an enormous pile of horizontal basalt lava flows. That's what this horizontal layering is through here. These are the lava flows. They're almost 2 kilometers thick, formed by volcanic eruptions that occurred 15 million years ago. That's million, not thousand, long before the last ice age even started. Now, these lavas are an important aspect of the analogy drawn between the channel scablands and Martian outflow channels. Remember, most of the Martian crust is made of just such basalt lavas, locally covered by sediments. Next one, please, Chris. The lava flows are spectacularly displayed in this image. Almost don't need to point them out, but they're here, for example, and then here in the background of the back wall. But you can also see that this large outwash channel that I'm standing in, that cuts down into them, also has some sharp bends along its course. Look, it goes through there and then suddenly turns left and goes off in the distance this way. Next one, please. And this third example of an outwash channel just emphasizes the point. Steep walls, flat floor, all cut into horizontal lava flows. It also nicely illustrates that the outwash channels are cut into a very extensive flat plane. How do you erode such precise geometries into a bedrock made of lava? Let's take a closer look. Next one, please. Here's a cliff about 50 meters high, where you can see several horizontal lava flows. There's a lava flow there, there's another one here, another one down at the bottom, and one even below that. Notice the vertical fractures, these things all through here, and even down here. They're referred to as columnar joints, and they're specific to basalt lavas. They're everywhere in the channeled scablands. What are they? They're cooling fractures. Basalt lavas erupted at the surface, cool and crystallize relatively quickly. As they do so, the cooling rock shrinks. And that shrinkage is expressed within the lava flow as sets of vertical columns that, if you could see them from above, would be hexagonal in shape. Carving channels in such a material is more like knocking over skittles, as opposed to cutting through, say, a massive granite countertop. Next one, please. Columnar joints come in all sizes, and the large versions in the channeled scablands aren't too shabby. Here are the columnar joints. Notice the cars, truck, for scale, and can you see that up there? Those are people. Those are climbers trying to climb up that rock column. Next one, please. Now, smaller outwash channels carved into the steep walls of the main outwash channel tells us about the sequence of events in the channeled scablands, and I'm referring to this one here, cut into the wall of the main channel. This hanging valley ends abruptly at the vertical wall of Grand Coulee and is sort of hanging way above the floor of the main channel. Next one, please. Here's another example to emphasize that the flat floor of the hanging valley, that's this up here, truly has been truncated by the erosion that formed the steep wall of the main channel itself. Now, in other words, the hanging channel was carved first, then truncated by the erosion that formed the main channel. Now, this is an important observation. It means that these subsidiary side channels are not tributaries that fed into the main channel. They're older. Next one, please. Now, this view along the axis of the hanging valley we just looked at confirms that it is indeed an outwash channel in its own right. It's got the flat floor, and there's the flat floor going in through there. It's slightly curvilinear. It's got the vertical walls. And it's, as I say, a slightly sinuous course. So here's the issue. We've established a time sequence, hanging valleys and then the main valley. But how much time are we talking about? Niagara Falls is eroding upstream today at 1 kilometer every 1,000 years. From what I've shown you so far, we cannot distinguish here between slow or normal and fast or catastrophic erosion rates. Next one, please. Dry waterfalls or cataracts seem to be pretty rare on Mars, as I've just tried to show you, and highly localized. But they're a characteristic feature all over the channeled scablands. This cataract here in midstream along a deeply incised outwash channel was not carved by the waterfall you see today, but something much bigger, which would have spanned the entire channel here and filled it from right at the bottom to the top. Although impressive by Earth standards, it's way smaller than the 400-meter high examples on Mars. Notice again the columnar jointing in the lava flows. It's actually up here as well, but I don't know if you can see it. And especially in this amazing erosional remnant there. See what I mean when I refer to skittles? Looking upstream from that cataract, we can see how the outflow channel zigzag. Whoop, next one, please, Chris. There we go. Looking upstream, the outflow channel zigzags back and forth, and then off like this in this direction, along its course, in a manner very reminiscent of the squiggly outflow channels on Mars. In the terrestrial example here, it's been established that old faults and fractures acted as lines of weakness and it has determined the zigzag form of the channel. Next one, please, Chris. And in the presence of similar fractures on Mars, all you would have to do is to round off the corners of the Martian example to produce something very similar in shape and form. Next one, please. Now looking downstream from that same cataract, again, we see the vertical walls carved into horizontal lava flows. Yes, you can see it. And how the channel continues to zigzag. In the floodwater model, the water doing the eroding fills the canyon to the brim while it's eroding it down. Next one, please, Chris. Such that even this stunning photo stolen from the internet of a superficially similar modern canyon actively forming today in East Africa totally underestimates the erosional potential of catastrophic floods. Next one, please. The most famous cataract, we're back to my photographs, by the way. The most famous cataract system in the channeled scablands is called Dry Falls. It's midway along Grand Coulee. And it's made of two adjacent cataracts, two adjacent waterfalls, separated by a narrow ridge of bedrock referred to as a rocky blade. Here we're looking upstream towards, and this is the entire cataract here, probably on Niagara scale, towards a 50-meter high curved headwall of one of these two cataracts. Floodwaters poured over the lip of the falls and formed a plunge pool, which you can actually see down here, at the base of the vertical wall before continuing their way downstream. Notice this white patch there. It's going to turn up in the next picture. Next one, please, Chris. Here we're looking obliquely across the trend of Grand Coulee. In the middle ground, here, to the right of that white patch, is the rocky blade, made of horizontal lava flows. You can see the lavas here. It's much longer than it's wide. The rocky blade separates the cataract we saw in the previous slide, that's this part here, from a second cataract, which is just as big as the first and which occupies the background of this image. It's here, coming around like this. Similar scale to what the other one was like. Luckily, erosion has breached the connection between the rocky blade and the twin cataracts, allowing to see both of them in a single field of view. Next one, please. In this image, looking perpendicular to the trend of Grand Coulee, we see the full extent of the length of the rocky blade. It's going from here to there. And that's about 1 kilometer long. What is this blade? It's a remnant of bedrock formed as two cataracts on either side of the rocky blade cut their way back upstream to the left in lockstep with each other. Why is this important? Why am I emphasizing this? Because it is one of the most characteristic features of cataract formation and therefore of outwash channel formation in the scablands. To drive this point home, next one please, Chris. Here's another example, looking obliquely upstream of twin cataracts carved into the plain above Grand Coulee itself. Hanging cataracts, if you like. Here's the cataract on the right. There is the rocky blade. And there is the cataract on the left, but it's got a hole in it. It's actually been further eroded and breached by ongoing erosion. Next one, please, Chris. Let me show you one last example of twin cataracts separated by a rocky blade. Here we're looking downstream from the upper head wall onto the lip of the main head wall of one of the two twin cataracts. There's the lip over which the water would have poured and cascaded. From here, the floodwaters flow directly downstream and into the Columbia River Gorge, which is just out there. Note the lake in the bottom of the cataract. Next one, please. Now here's that lake. Here's that lake again. We're looking downstream along the axis of the cataract towards the Columbia River Gorge, which is disappeared off the edge there. And the bedrock on the right, that's this stuff coming through here. That is the rocky blade, narrow rocky blade that separates this cataract from its twin, which is further to the right and therefore out of sight on this image. Next one, please, Chris. Finally, look at Steamboat Rock, over 100 meters high, sitting isolated in Grand Coulee. It's probably the most iconic tourist attraction in the Channel Scablands. That's this whole thing here. What is it? How did it form? Local geologists who've worked on this interpret Steamboat Rock as the largest remnant rocky blade in the area, isolated as its flanking cataracts cut their way back upstream to the right and completely left it behind. Next one, please, Chris. So here's... Skip this one. Nope. Go back, Chris. Go back one more. Go back one more. Okay, we missed it. Not to worry. We'll just go to we'll stick with this. Here's my first take-home message tonight. Twin cataracts with rocky blades are a common and characteristic feature of the Channel Scablands. Why aren't they common on Mars? Are they even present? What I was going to say was, do you see them in this picture? Well, it's a picture I've already shown you, but unfortunately I seem to have dropped it out of the sequence. Not to worry. Next one, please. And again. There we go. As I've already told you, the Martian model for the formation of outwash channels by catastrophic floodwaters is based upon assumptions and computer models. So, okay, what's the direct observational evidence that I can show you in favor of erosion by catastrophic floodwaters in the Channel Scablands? Next one, please, Chris. It's this. Boulders of basalt lava, that's what these things are, all over the place. The horizon there is as far as you can see, out to the horizon. The ground is absolutely covered with these things, probably spaced at no more than a meter or two distance from each other. And where are we located? We're at the downstream end of Grand Coulee. And these only form there. Geologists interpret these as shot, blasted from a shotgun. And that shotgun's represented by the floodwaters rushing down through the constrictions of Grand Coulee. In order to carry these and throw them tens of kilometers over this flat ground requires enormous volumes of water, traveling at frighteningly high speeds, which I'll come to in a moment. Next one, please. There are also large potholes carved into the flat floors and benches of bedrock in the outwash channels. They also provide a basis for estimating volumes and speeds. I managed to photograph these. There's one there. There's another one there, which is actually breached as further erosion has gone on. But these are actually small examples. These were the only ones I could get high enough to see. The large ones are easily not only the size of this auditorium, but probably the size of this museum and bigger, perhaps even including the car park. In addition, the outwash channels of the Scablands form a loosely interconnected system of channels, with water passing from one channel to the next on its way downstream. And here's the key. In several cases, not all, the floor of the downstream channel stands 100 meters higher than the floor of the upstream channel, which means that water in the upstream channel had to be at least 100 meters deep to even start to leak downstream, where it then cut another channel over 100 meters deep. And it had to be fast. So that's it. Almost all other observational evidence is equivocal in terms of discriminating between normal and catastrophic erosion rates. Next one, please, Chris. So in the Channel Scablands, putting it all together, you get a fascinating dynamic model that I'll summarize in this wide field overview of dry falls. The dry falls are up here. That's one cataract, and the other one's over here. And its rocky blade, seen from up there. And notice, of course, the plane that all this was cut into. Floodwaters were catastrophically released from glacial Lake Missoula to the east about 15,000 years ago towards the end of the Ice Age, flowing at speeds of up to 110 kilometers an hour across an extensive flat plain underlain by horizontal lava flows full of closely spaced cooling fractures. Floodwaters up to 100 meters deep, even on the plain, cut outwash channels up to over 100 meters deep themselves into the bedrock, principally by a mechanism of cataracts eroding their way back upstream. Note that if the plain was submerged, then the outwash channels must have been overfilled, and the cataracts themselves were submerged and out of sight. From the air, had you been there, all you would have seen would have been a water surface with standing waves, lots of standing waves, gently inclined to the west, which is where the Pacific is, which is where those waters were going, with local indications of turbulence at depth marking where the cataracts were. And the whole thing would have exploded and subsided. I knew I was going to do this. Subsided, not subsidized, subsided. Now that's a catastrophic flood within a week. Most local geologists believe that in fact there were numerous floods, but can't agree on how many, but they all agree that the features I've shown you were the product of the big one, which would have been the last one. Next one, please, Chris. So in conclusion, does the channeled Scabland story fit the outwash channels on Mars? Well, yes and no. We've seen the central role played by cataracts retreating upstream in the formation of outwash channels in the northeastern US. But observational evidence of such a mechanism is confined to the downstream end of just one channel on Mars. And there's nothing, next one please, Chris, nothing about that valley that says that erosion that formed it had to be catastrophic. Planetary scientists studying Mars who favor the catastrophic floodwater scenario have a lot of unanswered questions to address, including one, where are the missing cataracts? You might think perhaps they've all been eroded away, but science cannot operate on negative evidence. So, why are geometrically similar features so different in size on Mars and Earth? And why are the Martian examples in particular so huge? 3, where did the huge volumes of water required for the catastrophic floodwater scenario on Mars come from? To date, no one has come up with observational evidence for the catastrophic melting of permafrost, though this is commonly cited by proponents of the catastrophic model. Fourthly, where's the observational evidence on Mars that distinguishes normal from catastrophic erosion rates? On Earth, it includes boulders and potholes as well as elevation differences, too small or too subtle to detect with the current platforms that orbit Mars. We'll just have to be patient in order to address this question. In addition, while the catastrophic floodwater model is the most commonly accepted explanation for Martian outwash channels, it's not the only one. Others include the highly contentious but serious suggestion that outwash channels were carved into bedrock by very fluid, low-viscosity lava flows at the surface. So what's my conclusion? Yes, indeed. Similar processes appear to have operated to form outwash channels on both Mars and in the channel Scablands on Earth. But more work is required on the part of planetary scientists before they can really determine if the processes that operated in similar proportions and similar rates on the two planets. The last word has yet to be spoken on this ongoing scientific debate. Thanks for listening. Now, I know I talked for a long time, but I have to tell you, I told you very little about what I actually saw in Washington State. There is so much more. I told you just about the erosional features in bedrock related to the actual formation of the channels and the cataracts. There is just so much more, again, which one can compare with so much more that's on Mars. I also had a number of side trips, including going to the Burgess Shale, which meant a 12-hour hike up into the Rockies. And I also went to Drumheller on the way home, and I went to see the most fantastic museum I've ever seen in my life, which is the Tyrrell Museum with its dinosaur collection. And what I'm going to do is on October the 24th, we're going to be putting on a special presentation. The details are here. Can we post this somewhere on the RASC site? so that people have this information, or at least we can put it on no, I think we should put it on the site if we can, because then people can get to it. All we would ask is, if you're interested, please contact Jim Thompson. He will be our host. It's actually his office's conference room, and they need to have some idea of how many people might turn up. But you're all welcome. It'll be a lot of fun. It'll be somewhat less technical than I've given you today. I will do a very brief overview of what I've shown you today, but it'll be more extensive with all kinds of discrete comments on my part. Thank you.
So folks, we're going to run about 10 to 15 minutes late, but maybe less than that. But I thought Simon clearly put a lot of energy into his presentation, and I really appreciate you sharing this, Simon. I actually feel really privileged. And Simon, you're a real fascinating person. After a career working in geology and now being retired, his interest and his passion has not waned one iota. So I'm really impressed with that, and you set a model for the rest of us. Any questions? Maybe we can take 2 questions for Simon. More than 2 people.
One here.
Go ahead, the fellow in the front there.
Have liquid water on Mars. How thick would the atmosphere have had to be, and how long did that sort of fade?
In order for water to actually survive as standing water, in other words, for there to have been a lake which was actually dammed up somewhere, which could then be suddenly released, you would have to have an atmosphere which is 100 times denser than the current atmosphere on Mars. The Martian atmosphere right now is 1% of the density of Earth's atmosphere. And you'd have to be in the very early period. There's, of course, a bit of a problem in that many of these outwash channels appear to be, if you think of the Martian history as a hockey game, many of them seem to have formed at about the halfway point, whereas the appropriate conditions on Mars for standing water might have been sort of during the first quarter. So it really is an issue as to where you derive this water.
Simon, you sound very much like the catastrophic flood geology scientists with the Creation Science Institute who have been examining these all over the world. And they credit the Grand Canyon, as well as the Scab lands, and also the planation surfaces that are found all around the world, like in Cape Town, to the great flood mentioned in the Bible. And that's what they say that's where the water came from, and the water is now in the Pacific and Atlantic Oceans.
Yeah, I think I was very clear that there is evidence for catastrophic flooding, and it's nothing to do with the elements that you cited. Each one of the elements that you cited can actually be produced by very slow normal erosion, as Niagara Falls, for example. It really takes some very special kind of evidence to really put on the table the idea of a flood, and a catastrophic flood at that.
Simon, I have more of a comment. I hope astronauts who go to Mars have your insights into geology. This is amazing.
Well, I can only there's only one geologist who's been sent into space.
Yes.
And the other astronauts that went with him to the moon did not have his training. The other thing is you've got to have the right kind of geological training. There's no point, for example, in sending a paleontologist to the moon.
All right, folks. I sadly have to stop the questions. I mean, Simon will be around, I'm sure, after the meeting here. Next up is the observer reports. If all of the observers showing their images, if you could come right up to the front right now, and we'll go through this. As Simon mentioned, if you are interested in attending his more in-depth talk, we will post the information, but also if you wanted to grab the email address of Jim Thompson and the phone number, we'll have that available after the meeting, so you can grab that. So first up is Rick Wagner. Oh, you're coming from the shadows.
So, do I have control, or do you have control? Oh, okay. Rob Dick was going to show this last month, and I was so disappointed he wasn't able to show it because the projector failed. This is his observatory. Shot it in the spring at his open house. It's quite a thing with some of the big professional observatories, so for fun we tried it at his place. basically I set the camera up on a 30-second exposure. We put a couple of lights in the inside, Rob Dick's amber lights inside the dome, and then just rotated the dome slit past the telescope. So you can actually see the whole telescope inside the dome, and then of course the nice skies he has in the background. Next. Comet Jackus. Now there's been some debate on the name. Of course, I saw somebody online said, how do you pronounce this? Is it Jocks or Jackways or something? And I'm thinking, come on, it's like a Canadian doesn't know how to pronounce Jacques. Except that it turns out the guys from the discoverers from Brazil. So he's Spanish. No, he's Portuguese. Oh, okay. So Chris Tarrant investigated with a friend of his who speaks Portuguese, and the best we can come up with is that the pronunciation of the name is probably Jackus. Anyway.
Which, of course, we prefer to call Jackass.
Yes, that's right, yeah. Yeah.
Sorry.
Now, this is the video, right?
Yes.
So this is Malcolm Park showed a wonderful picture of the comet at Starfest, and so the very next night when I got home, I started taking pictures. So this is about 2 hours of 2-minute exposures. Now what I thought was interesting, I doubt if you'll be able to see it on there, but there is a subtle hint of a tail going along north of above the comet. And so I thought, I should be able to pull that out better. So I took all these images and I stacked them in a program called Deep Sky Stacker. And what it will actually do is it will actually stack all the images together twice. So once it aligns all the stars so you get a nice star background, then it realigns all the images on the comet so you get a nice bright sharp comet, and then it puts the two images back together to give you one image, which we have next. So here, well, unfortunately Deep Sky Stacker didn't actually do a very good job. So what I did was I took the two stacked images and created a combination myself. And so as a result, what you can see in the background is you can see a faint misting of the trails of the stars. However, it does show the tail much better. And in fact, do I have a laser? You can actually start to get hints that there might be a dust tail coming out here, and then the gas tail going up here. And also another interesting thing up here is a nebula called Sharpless 2-170. It's the 170th member of a large catalog of nebulae. While I was doing all this, a lot of this processing is done in 32-bit images. When you bring them into Photoshop, you have to convert these back to 16-bit images that you can actually work with easily. And there's a number of different ways you can do that to reduce the amount of information. And one of them, as I'm clicking through, because I've never done this very often in the past, and so I'm not very experienced, so whenever I want to do it, I try out all the different techniques. There's 4 different tools they have in my version of Photoshop. And one is called highlight compression. And if we go next, it really brings out a huge amount of tail. I was just stunned when this came up. So there's an awful lot of stuff. And the dust tail, I think, is beginning to show up much more strongly. So I was really pleased with that. Next. The Venus and Jupiter conjunction was last month. And I went out about 4 o'clock in the morning, canoed out to a little island off my place, and watched it rise. Got a whole bunch of pictures, then went off and did some fishing, and went home for another breakfast. Next. So imaging in the out from behind my place started on just an interesting star field. This is DODZ9. It's a collection of, I think, 11 open clusters. Dolidze Jemshemshevishli something. With more practice, I could probably pronounce it. Anyway, this is, I think, about the best one of their clusters. Most of them are pretty small and obscure. But what's interesting to me is there's a bunch of dark nebulae around here. There's quite a lot of interesting detail in there. That's about an hour exposure. This is a series I did of the Scutum star cloud. And of course, this is M11, one of the nicest open clusters in the sky. This whole cloud here is easily visible to the naked eye. And in fact, this area up here I find just wonderful in my 8-inch telescope with like a 30-millimeter eyepiece. It becomes much more stark than this. This half of the field of view is just jammed with stars, and these are much less visible in a telescope. A lot of these stars are actually quite faint and below the limit. This is 4 frames, so there's actually 4 separate pictures, each one about an hour and a half exposure. And again, lots of very interesting dark nebulae. I thought that was a particularly interesting one, very sharp outline, very dark. Next. Sharpless 2-171, just coincidentally, the Sharpless 170, where the comet was about a month earlier, is just outside the field of view here. So it's almost in the same place. Fairly nice grouping of stars up there. So this is a ionized hydrogen region. 2 frames, one north, one south. The south one is about an hour and a half of data. The top one is only about a half an hour, so I need some additional data on that one. Next. This is the central star in Cygnus, Solder, or Gamma Cygni, and IC 1318 nebula there. You can see huge amounts of nebulosity extending all out here. Just caught the tip of the Crescent Nebula down there. Some very nice dark nebulae again. This is a dark nebula here stretching across in front of the nebulosity. Nice star cluster here. I think that's M29 there. Another one up there. I haven't even bothered to identify them all. This also is 4 frames, each about 2 hours of exposures with a DSLR. And I think that's it. All right, thanks.
Just wondering, Rick, do you use filters at all for your
No.
water? What you see is what you get.
Yep.
Great. You ready?
Thank you, Rick, for sharing. Outstanding. Okay, next up, Gordon.
I mean, Julia put forward.
And Julie, sorry.
And can't be here without my assistant. Okay, I've got 5 planetary nebula for you tonight. They were done over a course of a couple of nights. The first one is NGC 6804. It's in Aguila, and it's a small fan shape. It's better with the ultra high contrast filter, and my sketch may have been a little off because as I was finishing it, it disappeared into the trees. So, next, please. This is 6905. Also, it's in Delphinus. It's also known as the Blue Flash Nebula. So I didn't see the flash, but it's fairly bright, large, mostly round, with seem to be some brighter strands in it. These observations are all done with my 12-inch Newtonian. Next, please. Here we have the Cheeseburger Nebula, 7026 in Cygnus. It's fairly small, quite bright. You can see the 2 fuzzy nuclei, and there's a slight hint of a slight hint of green. Maybe the cheese has gone off, I'm not sure. Next one, please. NGC 7027, also in Cygnus. It's fairly small. What's that look up there? Yeah, it's fairly small, very bright, with a brighter core and a bright inner halo and then a fainter outer halo, and a definite green tint to it. And oh yeah, without the ultra high contrast filter, this appears fan shaped like the first one. And it's a few guides I've read, they refer to it as being fan shaped. So, and last but not least is 7048, also in Cygnus. And it's without, oh yeah, non-existent without the O3 filter. Couldn't see it at all. It's quite faint, round, slightly brighter in the center, down near the star. Green one's the pointer?
Yep.
Down near, right in here is a little bit brighter than the rest of it. And stop playing my notes. And in averted vision, it had a sort of a mottled appearance. That's it. Thank you.
Okay, thank you. Remember that Gordon is selling the tickets for the annual dinner, so you can approach Gordon after the meeting.
Meet our next president? Hopefully. 3 slides to show, but first I'd like to thank Eric, Eunice, and his team working on videotaping this. I just checked on Ustream.tv. We're close to 2,500 hits for the year since November 1st. So excellent, excellent. So we had the supposedly grand aurora a couple of weeks ago that was supposed to have, we had an X1.6 solar flare that was supposed to really deal us a good blast, and it just got one slide of red. Eric got some better shots, but because Joe Bonner came over to my place in South Mountain and we were looking for the great green in the sky that didn't materialize. So it was probably dark, it was hanging out there probably all the time, just we didn't photograph it. And I stretched it, as you can tell, till it healed. And just a 30-second exposure. Next slide, please. I believe I got these zodiacal lights. Again, not enough frames, not enough subs, or even a long exposure. It's about 45 seconds. But there is a hint visual in the sky right through here, and we have Jupiter and the Beehive. So I'm gonna have to do more subs on that, because starting from October 20th for the next 2 weeks, you'll get to see these zodiacal lights in the morning before sunrise. And the last slide is the trio of Antares, Mars, and of course the good old moon. So we have a nice lineup in the sky. Thanks, folks.
Thank you, Gary. And I think that leaves us with Bob, I'm guessing.
Oh.
Paul? Oh, yes. Paul, are you here? Right. Paul, please.
Thank you.
I'm here to bring joy into your life. As astronomers, we get ticked off when clouds mask special opportunities like eclipses and such. So I just want to share this with you because we weren't alone here in Ottawa. So just a couple of satellite images from the time of the eclipse. This was at the beginning of totality of the lunar eclipse just a couple days ago, and you can see most of Ontario was pretty rocked with clouds there. In fact, about the only place that had any clearing was a thin sort of corridor between the Niagara Peninsula and up towards Georgian Bay. If we advance that half an hour, that's at the beginning of the eclipse. That's about mid-eclipse, and again, you can see that was that corridor maintained there. At the end of the eclipse, about an hour later, they may have gotten a little bit of a view in Kingston. I don't know if anybody else saw it down there, but no, not down in Kingston. No, I didn't think so. It didn't look very good. So as you can see in Ottawa, we were totally socked out. But before you go swearing at the weather gods there, next one. So this is a similar eclipse that I shot 7 years ago, actually. The moon was in about the same position. In fact, this is a better alignment of things because at this point in time, the moon was about 11 degrees above the horizon. The sun was about 11 degrees below the horizon, and still you can barely see the eclipse there. Right, it's just faintly visible. For the eclipse that we did miss, moon was in fact lower in the sky, would have been about there, and the sky would have been brighter. So it would have been very, very difficult to see it, and we would have needed optimum conditions anyway. So bottom line is, you didn't miss much, right? And to give you something to look forward to, the next really good opportunity we have for a lunar eclipse comes next September, the 25th. The moon's going to be up much higher in the sky. It will be at night, so we won't have to worry about dawn light creeping in there, and then we'll all just have to worry about the clouds. So that one's worth chasing. This one that we just missed, definitely not worth chasing. So
There's one in the spring, isn't there?
yeah, but it's
It'll be something like this, but even lower.
it's even worse. Yeah, I believe it's in April.
April, yeah.
April, yeah.
But then
So-
after September, that's until 2018.
Yeah. So if you haven't really seen a good lunar eclipse there, the one next September definitely worth chasing if you like such things, because they are glorious when you get a nice clear night and when it's dark. Yeah, we didn't miss too much. So. Anyway, the thing to look forward to, Gary already mentioned it. Next one there, Chris, is partial solar. This one I shot. Remember this one, Gordon, out in the burnt lands? This is from a couple of years ago. We only had about a few minutes, really, here in Ottawa. The one that is going to happen on the 23rd, not much better, a little bit better. This one from 2 years ago, at the time that the sun set, it was only about 19% coverage by the moon on the disk there. This time around, it's about twice that, about 29.6%, and as Gary showed in his slide, it will occur on that edge of it there. But again, it will be a short duration event. The sun will set before we get a much larger portion of it eaten out. You'd have to be out west. So if anybody's planning a trip out to Vancouver or going to be out further west than we are here on that day, check it out. If you're interested in imaging this, be careful, because depending on how clear the sky is and stuff, you really don't want to focus too much direct sunlight on your CCD chip. That can be a little bit damaging. Filters definitely recommended. So we'll cross our fingers, and hopefully next month we'll see some observations. Thanks again. Good luck.
Several weeks ago, I fired up my observatory out in the country, and one of the first things that happens when you turn the dome on is that it rotates and finds its home position. When I turned it on, the dome started to go round and round and round and round. So I did shut everything off, and I went up there and checked it out, and the cute mice that I was trying to dissuade to move out of my observatory had made a home in the control box and had eaten most of the wires. And now it's using slightly more aggressive approaches to deal with mice. If you have your observatory in an outdoor shed or something, be forewarned, this season is apparently very bad for mice, so take appropriate caution.
Okay, one of the things I was talking to Bob about in the previous meeting was having him do a live demo of his observatory. Remember, he talked about the remote setup. Maybe we can get him to do that in one of the future meetings. I think we're talking about doing around October, November, anyhow, Bob. All right, let's wrap up here real quick. So if you want to watch this meeting again, you can watch it on Ustream. Just Google Ustream RASC Ottawa, and you'll be able to watch it. It's posted within minutes after this meeting here. Our library, our astronomy library, is in the Science and Technology Museum, so unfortunately we don't have a pick of the month now. We normally meet at Kelsey's, so which is close to the Science and Technology Museum. I didn't think about this one here. 30 seconds. Any suggestions for a meeting place in the area? Anyone?
Or go to Kelsey's, it's not that far.
All right, Kelsey's it is. So everyone's welcome to join us at the social event at Kelsey's at Saint Laurent and Lancaster, 2 blocks from the Science and Technology Museum. Okay. Tonight we had 115 people that attended here locally, and I don't have the number remotely here. Like Gary said earlier, it's worth pointing out some people who really worked tirelessly behind the scenes. Eric and Eunice, Chris, and
Mike Mogadam.
and Art and Ann. Never seek recognition, these folks, but they just do it for your enjoyment here. So thanks to them. Really, truly. Next meeting is at the same location, the Aviation and Space Museum, and it sounds like we're going to be here for a while. So we'll let you know, obviously, for postings if something were to change. Okay. Something else I want to point out as well is that at the next meeting, you'll see emails that'll come out about this. you have to park at a different location, okay, because there is another event going on tonight. So this is the main entrance that you walk through here. This is parking lot number 1, which is where you parked your cars. Next meeting, and we'll describe, as I said, we'll document this really well. You have to park in parking lot number 2. Okay, so I'll mention that a couple of times. November meeting, we got 2 speakers. Richard Alexandrovich will be talking about Epsilon. I can never pronounce this. Help me out. Origai, thank you. And the mystery behind that, and also Rick Wagner is be talking as well, and we'll be posting that. In December, a special guest speaker, Bob Berman. You may know him from his regular feature in Astronomy Magazine. He's coming to this meeting here, and if you go on our Ottawa RASC website, our meeting agenda is here. Meeting agendas are posted. You can read about what he's going to talk about. Bob is a very gifted speaker and writer. Okay, he has some of my favorite books are written by Bob Berman. I am delighted. He shared with me portions of what he's going to be talking about. It is going to be maybe the highlight of the year. Okay, so the December meeting is December 5th, I think. You don't want to miss that meeting. Okay, folks. That closes the meeting. We're going to do the door prize. Thank you all for attending. Let's get the lights and we'll do the door prize.